A rectangular tank measuring 30 cm by 12 cm by 16 cm contains some water. A cubical container with sides measuring 12 cm is completely filled with water. So take note, you have two different tanks here. One is a rectangular tank, the other one is a cubical container. And the cubical container means it's made up in the shape of a cube. All of the water from the cubical container is poured into the rectangular tank. And as a result, the tank became 2 out of 3 full. What was the amount of water in the tank at first? All right, so the idea is this. There is a change involving the water in the original rectangular tank. Okay, so you have a tank, the three dimensions are given. Do take note, whenever three dimensions are given in this manner, the third one is always the height. Okay, the first two, either one can be the length, whichever is the length, whichever is the breadth, doesn't matter. The third one is always the height. All right, and it contains some water. So we don't know how much water is in there at first. All right, so this is one thing to bear in mind. There was already some water at first inside. Now then there was a transfer. All the water in the cube was transferred into that tank, and as a result, the tank became 2 out of 3 full. Alright, so this became 2 out of 3 full. It's a very useful information because with this, it means that you can first find out what is the volume of water in the end, inside the tank. Alright, so using that information, I simply know its length times breadth times height. Now, length times breadth times height is the capacity of the tank. All right. So you have to multiply that capacity by 2 out of 3 so that you know what is the volume of that bottle that was in there in the end. Okay, the final volume of water. So take note when you do such questions, all right, whenever there is content, okay, whenever there are contents inside the container, it could be water, it could be small solid, whatsoever, all right, you should be interested in the volume of these contents rather than the volume of the whole container. The capacity of the container is the last thing you worry about, is probably not important. Okay, so you notice that I did not start off my first step with taking 30 times 12 times 16. Why? Because that is the capacity of the tank and that is not important. I do not need that actually. Alright, so focus more on the volume of the things that are inside the containers. Now 3840 is the final volume of water. And this 3840, some of it came from the water that was in the cube. Alright, and we know the cube, it measures 12 cm size, very nice. So they give us 12 cm measurement, and they told us it's completely filled with water. So with this information, we can find out the volume of water that was transferred to the rectangular tank. Alright, so we call this volume of water added. If you don't like to use the word added, you can use the word transfer. So transfer came from the cubical container, which is a size of 12 cm each and completely filled. In other words, I can find out the total volume of water that came from the cube simply by doing 12 times 12 times 12. So this also acts as the capacity of the cube, yes, but it also serves as the water that was fully filled inside the cube as well. Okay, now working backwards, do you realize now I can find the water at first inside the rectangular tank? So the water in there was this much, and then this water that came from the cube, okay, was poured over to the tank such that this was the final volume. Hence, if I like to work backwards to find the water at first, the water at first is lesser than at the end. So if it's lesser means I have to subtract. Take this, subtract the water that came from the cube. And that's it. All right. This is your volume of water in the tank at first. This is in cm3 or in ml. So either one is fine. If you put cm3 is okay also.